The question that I'm going to look at now was sent to us by Njabulo Zalo. Njabulo, thank you so much for this question. It is, you said particularly you want to focus on 4.2 and 4.44. I'm going to do all of them because obviously we need information from the previous sections of the question to be able to answer 4.2 and 4.44. So yes, let's see what it says. The diagram is on the screen and it says the following. In this diagram here, a circle that has a center at the origin. Okay, so that's the big circle, has a center at the origin. It passes through point P. PO, which is a radius of the big circle, is a diameter for the smaller circle, okay, that has a center at M. So this little part is equal to that little part there. Then it says the diameter RS, now that's useful information. If RS is a diameter of the bigger circle, then we can say that those two are equal. So if we have coordinates for R and for S, we can then find the radius of the bigger circle. Actually, we only need R or S for that. So that is the information that they gave us. Good. Now it says for the first section here, 4.1, says find the coordinates of M. Okay, now what do we need about M? What do we know about M? M is the midpoint of OP. Well, O we have the coordinates for. It's the origin. It's 0, 0. And P was given as 4 minus 6, folks. So if you want to find the radius of that circle or the coordinates, you just need to apply the midpoint formula between O and P. P's coordinates is 0, so look how easy this is. M will then be the point 4 divided by 2, which is 2, minus 6 divided by 2, which is minus 3. That's all you had to do. That's the point 2 and negative 3. The 1 point was 0. Now remember, we're not going to give you a mark for copying a formula from a formula sheet. Okay, you know that. So you can go straight. This question was actually just for 2 marks. Your 1 mark is going to be for the x coordinate. The other mark is going to be for the y coordinate. What's easier marks than just taking numbers and dividing them by 2? Quite easy marks for you. The second part has 3. This is the part Njabulo that you wanted us to focus on. It's got 3 sections. The first one says find the equation of the largest circle. Then it asks us to find the equation of the smallest circle in a particular form. Be careful. Make sure you leave it in that form. And then the third part, the equation of RS. Now RS is that diameter. And again, in a particular form, y equals mx plus c. So the total of that question is going to be 8 marks. Not a difficult one, but make sure you answer the question that they asked you to answer. Let's have a look. 4.2.1. They ask us to find the equation of the largest circle. Now remember what we said. If a circle has a center at the origin, we know it's x squared plus y squared. No other thing. X squared plus y squared, because it's x minus 0 plus y minus 0. Hello? X minus 0 is still x. Okay, so don't do unnecessary things. Then we have a point on the circle, point P. So the radius is found by 4 squared plus this minus 6 squared. Now this is 16 plus, what is that, 36. So that gives us 52. So our equation of our circle that has centered the origin is x squared plus y squared equal to 52. And they did not really, yeah, that's for 2 marks. So the 2 marks will most probably go in for working out that radius. Okay, so the calculation for the radius and then the final answer of 52. Now remember, that's radius squared. So if you're ever going to work with that length of the radius, you've got to square root it. Remember that. Okay, 4.2.2 asks us to find the equation of the smaller circle. Okay, now and here it comes in play. Look at this. The radius squared is what we have here. Now, the root of 52 is, let's see if we can do anything with that. 52, the square root, I don't think we'll be able to. Yeah, we can. It's 2 times 26. So 4 times 13 then, instead of 2 times 26. And that gives us 2 root 13. Now we have the length of OP. Be careful. It's the length of the diameter of the smaller circle. Folks, there's so many traps here to fall in. It's the length of the diameter. To find the length of the radius of the smaller circle, you have to halve that answer. Okay, so let's put our information here. 2 root 13, which means this is root 13, and so is this the root of 13. You must be wide awake in your exam, folks. Do not fall into simple little traps like this. Okay, now we're going to head for the equation of the smaller circle. Remember, that circle has an off-centered center. By that I mean the center is not at 0, 0. So it's x minus a squared plus y minus b squared equals the radius squared. Okay, let's write it down. So the circle's equation is x minus 2 all squared plus y, be careful, double negative here. So y plus 3 all squared is equal to the square of that radius, and that is 13. That earned you a full 3 marks. Okay, your marks most probably for the center being used correctly, and then 1 for that correct radius. Okay, please be awake. That was a nice catch. The next question says, find the equation of RS. Now let's see. RS is this diameter here. Do I have enough information to find that? Well, I do not have any other information about the points. No, I don't have information about the points. I've got the circle. I do not know whether, let's see, did they give us RS is the largest circle, it's tangent to the smaller circle at O. That just tells us that they touch here. Okay, so now we need to find the equation of RS. Let's have a look. To find the equation of RS, I am a little bit worried. The only thing I know here that's going to work for me are that these two here are perpendicular. Why is that the case? Well, they told me SR is tangent to the smaller circle here at point O. So I might be able, there we go. I can find the gradient. I hope you saw that. Because of that perpendicular relationship, I've got the gradient of SR. I just need a point on it, which I also have. It's the origin. Okay, so let's work out. First of all, 4.2.3. First of all, I need the gradient of OP, the radius over there. Now that is minus 6 over 4. And that simplifies to minus 3 over 2. That's the gradient of this little piece, OP, over there. SR, they told me, is a tangent to the smaller circle. So that relationship is orthogonal, or it's a perpendicular line. So the product of those two gradients has to be minus 1. Let's have a look. So the gradient of RS is then 2 over 3. If you multiply those two together, you get the minus 1. And from that, the equation of SR will be the following. Now, let me just get rid of that. There's too many arrows here now. So let's say the equation of that SR here will be y is equal to 2 over 3x. Folks, it passes through the origin. The moment you see a line on a diagram that passes through the origin, you've hit the jackpot, because all you need is the gradient. You just need the gradient of that line, and Bob's your uncle, you've got its equation. Okay, the last part of this question, or the second last part, 4.3 is for 4 marks. Determine the length of the chord NR, where N is the reflection of R in the x-axis. Oopsie, let's see. R has a reflection in the x-axis, not in the y-axis. They say NR, N is the reflection in the y-axis. Sorry, my mistake. So there we go. So we have that line there, and we have this point here, which is indeed point N. It's a reflection of point R in the y-axis. Now, folks, the y-axis is the mirror line. So the distance from the mirror line to this point is the same as the distance from the mirror line to that point. So all I need to find is the coordinates for R. If I have the coordinate for R, the x value as, let's say, randomly 5, then the length of the line will be 10. It will be 2 times 5. So let's see how we can find the coordinates here for this point. So for 4.3, and I'm out of your screen most probably again. There we go. For 4.3, the following is what we're looking for. We're looking for the x coordinate for point R. Once we've got that, we've got the length. Do we have any equations that we can draw on here? Let's have a look. We have the equation of the biggest circle, and we've just found the length, or the equation for XSR, which was y is 2/3 x. So what happens at point R is the circle x squared plus y squared equal to 52 is equal to the line with that equation. Now the equation for the line is 2/3x. Now again, we've got ugly fractions, so please work very slowly. Remember, when you square a fraction, you square the top and then you square the bottom. I don't like working with fractions, so I'm going to take a safe route out maybe. Let's see what happens here. X squared plus 4/9, x squared is 52. Now I can say that this is 9/9, or I can multiply everything with this 9. Just to get rid of the fraction. That's always the safe way for me to do it. So plus 4x squared remains, and then I'm faced with a huge number. 52 times 9 is 145, 450 plus then the 18, which gives us 468. Okay, it's an ugly number, but it's an ugly number for a few seconds. After that, we're going to divide it away. So 9x squared plus 4x squared is 13x squared. Let's make space. So we get 13x squared is equal to 468, which makes x squared, if you divide 468 by 13, folks, you get 36. And there you get two answers. X is 6, or you get another answer. X is -6. Now be careful, we don't need both those answers. The one is the answer for the reflected point's x coordinate, and the other one is the coordinate R on your graph. If we just go up here, that means that this distance from there to there is 6, x coordinate is 6, and the x coordinate here is -6. We don't know the y coordinates yet. Okay, but we don't need them. They asked us find the length of NR for 4 marks. So all you need to do, double up the 6 and you get a 12. Let's round off the question. NR is therefore equal to 12 units. That was quite nice. Section 4.3. Now, I'm sure you'll agree with me in Jabulo that we needed all the other workings for us to answer these questions. Your last question, which is question 4.4, or section of the question is 4.4 that you asked us to look at, and that is also for 3 marks. So for 4.4, they say, the circle with the center M is reflected about the x-axis to form another circle. Now let's go to our diagram. If I take this circle here, and I reflect it in the x-axis, remember this is the x-axis, then it means that the distance to the x-axis here is going to be equal to the distance, the x-axis at the top. So then they're also asking us, after they've said that, they said that circle will be centered at K. Okay, so remember, if we reflect in the x-axis, the x values remain the same. It is the y value that changes its sign. Njabulo, be careful. So for point K, which is actually that point, let me change color. Point K is this point over there. Okay, the distance to the mirror line is the same. The mirror line is the x-axis. Okay, so that point has an x-coordinate of 2 and it will have a y-coordinate of 3. Now remember I said the x values remain the same. Now what does that mean? The circle at the bottom with the center M cuts the x-axis at 2 points. Those x-intercepts are going to remain the same. So if I draw the circle up here, the circle will have that center and it would lie like that. Now it's asking us the question, it's a beautiful question. Calculate the length of the common chord of these two circles. Now where's the common chord? Let's see. The common chord is from that intersection point to that one. I'm going to see if I can get another color. I'm just going to use red there. So we want the length of that little chord over there. That's the common chord. Okay, so did we even need the information about the top? Yes, because that is how the common chord was formed. But we're now going to go back and we're going to find the x-intercepts of the circle with the center M. Because if we have that x-intercept we've got, we just need the second one that lies over here. Okay, and then we have the length of the common chord. So the length of the circle at where the center, it's this circle that we're working with over there, folks. Okay, so please be careful now. At here, the y value is going to become 0. Okay, so we're going to start and we're going to say there, let me use the yellow, x minus 2 all squared plus 3 squared is 9 is equal to 13. That jumps over to the other side. X minus 2 all squared, 13 minus 9 is a 4. And then we can see that x, now please don't go and square this out and form a new trinomial. You've got a square on the one side and you have a square on the other side of that equation. Just take the square root both sides and don't forget the plus or minus. So this becomes x minus 2 is plus or minus 2 over there. And therefore x will be 2 plus or minus 2. You get your one x value as 0. This is not the one we're looking for. You get your other x value as 4. So this here is 4. That there we know is 0. The length of the common chord is then 4 units. So let's just see if they named the common chord. Calculate the length of the common chord. So we just say the common chord is 4 units long. Okay, folks, now what did we work with here? Let's quickly just talk about what this question allowed us to do. The question worked with a circle that is within a circle. The one circle was centered at 0, 0. The other one was off center. They gave us a diameter of the bigger one and they gave us the diameter of the smaller one. And they said that the bigger diameter was tangent to the smaller circle. That helped us with finding points and finding equations of lines and that type of thing. But the beautiful thing here was that they started working with transformation geometry, where they said the one is reflected. Remember, the 1 point was reflected over the y-axis. What happens if we reflect over the y-axis? The x values change sign. And then they had the cheek to say, okay, the circle is now going to reflect in the x-axis, which means all the points that was on the initial circle at M, Their X values remained the same, but their Y values changed sign. Not that we needed that information, but remember we needed that information to find where the common chord is. Once we saw where the common chord was, we saw, but hang on, we don't really need this. We just need that X-intercept. And that will give us the length of that common chord.